Good day, ladies and gentlemen. My name is Chinedu Kingsley Friday, and I'm here today on behalf of a team of researchers to present this paper today. The team include myself, Chinedu K. Friday, Ifeanyi S. Umeh, and Howard O. Njoku. The title of our paper is A Comparison of Satellite-derived and Ground-Measured Wind Characteristics of Selected Nigerian Locations. Introduction. Wind speed data are crucial for determining the wind energy resources available in any location. These data help to establish the wind speed patterns in a given location of interest and are used for quantitatively analyzing the wind energy potentials and for designing and deciding on the establishment of wind power plants. Wind speed data can be obtained from databases of satellite-derived atmospheric data, such as the online NASA data, which offers freely accessible data. Wind speed data can also be obtained by measurement at ground-based weather stations, such as those operated by the Nigerian Meteorological Agency, NIMET in Nigeria. Data obtained from satellite-generated database may not be as reliable as the wind speed data obtained from ground weather stations. They help to supplement for locations where ground wind speed data are not available. Scope. The analysis carried out in this research was limited to daily and monthly mean wind speed data from 6 locations shown in the figure in Nigeria: Enugu, Abuja, Lagos, Port Harcourt, Maiduguri, and Kano State for the years 2013 to 2017, obtained from the National Aeronautic and Space Administration (NASA) and the Nigerian Meteorological Agency (NIMET). Methodology. Wind speed data were obtained from NASA-SSE database, which is satellite generated. Monthly wind speed data were obtained from NIMET database, which is ground station measured. A 5-year data for the years 2013 to 2017 were obtained from the NASA, SSE, and NIMET databases. The following statistical measures were considered. The average wind speed was calculated using equation 1 as shown. The coefficient of determination were also calculated using the equation as shown. Results. For Abuja, the following results were obtained. Figure 2 shows a comparison of mean monthly wind speed for Abuja. The NASA SSE data had a 5-year mean wind speed of 2.33 meters per second, while the mean of the NIMET data was 2.1 meters per second. The highest wind speed was recorded in the month of December for the NASA SSE data, while it was recorded in the month of March for the NIMET SSE data throughout the years of the study. The lowest wind speed data occurred in the month of October for the NASA SSE, while it occurred in the month of November for the NIMET data throughout the years of the study. The NASA SSE data had a 5-year mean wind speed of 2.69 meters per second, while the mean of the NIMET data was 2.59 meters per second. This is for Enugu location. And figure 3 shows the comparison of mean monthly wind speed for Enugu. The highest wind speed was recorded in the month of August for both the NASA SSE and the NIMET data throughout the years of the study. The lowest wind speed was recorded in the month of November for both the NASA SSE and the NIMET data throughout the years of the study. From the graph, the blue line shows the NASA-SSE data, while the orange line shows the NIMET data. For Kano State, the result obtained from Kano State analysis. The blue dot on the graph for figure 4 shows the NASA-SSE, while the orange line shows the NIMET data. The NASA-SSE data had a 5-year mean wind speed of 2.48 meters per second, while the mean of the NIMET data was 3.83 meters per second. The highest wind speed was recorded in the month of February for the NASA-SSE data, while it was recorded in the month of June for the NIMET throughout the years of the study. The lowest wind speed occurred in the month of September for the NASA-SSE, while it occurred in the month of October for the NIMET data throughout the years of the study. The NASA data greatly underestimates the NIMET data. You can see the differences in the graph. Figure 5 shows the comparison of mean monthly wind speed for Lagos. The NASA-SSE data had a 5-year mean wind speed of 3.66 meters per second, while the mean of the NIMET data was 2.07 meters per second. The highest wind speed was recorded in the month of July to August for the NASA-SSE data, while it was recorded in the month of August for the NIMET data throughout the years of the study. The lowest wind speed occurred in the month of December for the NASA-SSE, while it occurred in the month of November for the NIMET data throughout the years of the study. The NASA-SSE data greatly overestimates the NASA-SSE data greatly overestimates the NIMET data. You can see the differences on the graph in figure 5. The blue line stands for the NASA-SSE data, while the orange line stands for the NIMET data. Figure 6 shows the comparison of mean monthly wind speed for Maiduguri. The results were as follows. The NASA-SSE data had a 5-year mean wind speed of 3.70 meters per second, while the mean of the NIMET data was 3.73 meters per second. The highest wind speed was recorded in the month of February for the NASA-SSE data, while it varied from month to month for the NIMET data throughout the years of the study. The lowest wind speed occurred in the month of September for the NASA-SSE, while it varied from month to month for the NIMET data throughout the years of the study. The NASA-SSE data overestimates the NIMET data in 2013, had better predictions for 2014, and slightly underestimates the NIMET data for the years 2015 to 2017. Figure 7 shows the comparison of mean monthly wind speed for Port Harcourt. The NASA-SSE data had a 5-year mean wind speed of 2.01 meters per second, while the mean of the NIMET data was 1.05 meters per second. The highest wind speed was recorded in the month of August for the NASA-SSE data and the NIMET data throughout the years of the study. The lowest wind speed was recorded in the month of December for the NASA-SSE and the NIMET data throughout the years of the study. The NASA-SSE data greatly overestimates the NIMET data for the years 2013 to 2014 and 2017, but slightly underestimates the data for 2016. Statistical comparison of the NASA-SSE and the NIMET data. This is a representation of the R-squared values calculated. For the Abuja data as shown in figure 8, for the Abuja data, we had an R-squared value of 0.2122. For Enugu, as shown in figure 9, we had an R-squared value of 0.3672. For Kano, as shown in figure 10, we had an R-square value of 0.0726. For Lagos, as shown in figure 11, we had an R-square value of 2.997. For Maiduguri, as shown in figure 12, we had an R-square value of 0.1008. For Port Harcourt, we had an R-square value of 0.1252. Conclusion: the R-square values calculated for the 6 locations showed that the NASA-SSE data does not properly describe the NIMET data. Thus, significant under- and overestimation may arise from the use of the NASA-SSE data for wind energy analysis. Thank you for listening.